Hi, this is Bill. I wanted to walk you through solving a circuit. It's kind of an unusual operation, and I think to just go through it simple step by step, we can figure out how to do it easily using very simple math. The first step in solving a circuit is to take a look at Ohm's law, which is the E equals I times R. Translated into English, that's the voltage equals the current times the resistance. Now you can take that simple equation and you can pull apart its other two parts, which is the current equals the voltage divided by the resistance, and then finally the resistance equals the voltage divided by the current. It's probably a good idea at this point to write those three equations down. Actually, it's all one equation, but just written in its three different ways. But I would write them down on a piece of paper right now so that you can refer back to them. Normally, when you're given a circuit to, quote, solve, unquote, you're given a schematic drawing like the one you're looking at right now that will have a battery, or at least a power source, and it will have some other parts of the circuit. In this case, there are three resistors: a 5 ohm resistor R1, a 10 ohm resistor R2, and a 15 ohm resistor R3. In this case, there's also a switch called S1, and there's a fuse up at the top left-hand corner called F1. When we set out to solve a circuit, we're going to do four things. We're going to find the total resistance of the circuit. We're going to find the circuit's current. We're going to find the voltages around the circuit, as well as, in some cases, the voltage of the battery or the power source. And we're also going to find power around the circuit. In this case, it's going to be the power that's dissipated by the three resistors, R1, R2, and R3. By the way, when power is converted to heat or light or motion, it's returned to the environment. Okay, the electricity is converted to heat, light, or motion, and then that is called dissipation. So what it means is that the current going through, the power going through this circuit is going to be turned into something else. In the case of just plain resistors, it would be turned into heat. The measure of how much heat it is turned into is considered power. And power is the one that's measured in watts, W-A-T-T. When you go about solving a circuit, you don't always have to do it in exactly the same order, 1, 2, 3, and 4. But a lot of times, it's a great way to start. So let's go ahead and start, and let's solve number 1 first of all, and that's finding the total resistance. Well, as you already know, the resistance in a circuit is going to be the resistance of each of the elements in the circuit. In this case, they're simple resistors, so we're going to look at the resistance of R1, the resistance of R2, and the resistance of R3. And we know to get the total resistance, which I'm going to call RT for total, it's going to be equal to R1 plus R2 plus R3. Okay? So we add them up. We have 5 plus 10 plus 15, and that's equal to 30, right? So the total resistance is equal to 30 ohms, and we'll use the symbol for ohms there. At this point, you might want to stop the video and or pause it and actually draw the circuit the way it's drawn here in the video and follow along and actually make your computations as I make mine and do the math at the same time I'm doing my math. Okay, now that we've found the total resistance, let's jot that down up near number 1 where it says find total resistance. So I'm going to go ahead and next to total resistance I'm going to put 30 ohms. And this is just so I can remember it for later. Now let's go ahead and find the circuit's current. So the circuit's current is going to be the second of the 3 formulas. It's going to be I equals E divided by R. Okay, so I is going to be the current, and that's what we're solving for. So what is E? E is the voltage, which we will pick up over here. That's the 90 volts. And what is the resistance? Well, the resistance is what we have up here, the 30 ohms. So we'll go ahead and write out that I equals E, which is 90, divided by the resistance, which is 30, and 30 goes into 90 3 times, so that's going to give us 3 amps for the current. So I'm now going to write that down next to number 2, finding the circuit current. So I'm going to put down 3, and I'm going to use small a for amps. So it's 3 amps. Now the next thing we're going to find, this is number 3, is going to be the voltage drops across each of those resistors. So we're going to start off taking the voltage drop across R1, which is a 5 ohm resistor. So if we look at our formulas again, we've got E equals I times R, that would be E for the voltage, equals the current I times R, which is the resistance. So in this case, for the first one, we're going to do E equals I. Well, we know what the amperage is. It's 3 amps. And we're going to multiply that by the resistance. And the first one right here is 5 ohms. So we're going to say that is 15 volts for the voltage drop across resistance number 1. The next one we're going to do is resistor number 2. So that's going to be the same amperage, and this time it's going to be times 10, which is the resistance, and that's going to be 30 volts. And the last one, which is down here, is going to be the amperage is the same. Don't forget the amperage is the same all around the circuit, times 15, and 3 times 15 is 45. Okay, so those are our 3 voltage drops on this circuit. So at this point, you might be wondering, how do I know that this is correct? Well, in the case of the voltage drops, the total number of voltage drops around the circuit, in this case it's 15, 30, and 45, if you add those up, you're going to come up with 90 volts. And how about this, guys? That equals exactly what is in coming out of our battery. Okay, so that's kind of a test to see if you've done the math correctly. Okay, let's go ahead and jot those numbers down, and I'm going to put them down next to the various resistors So the voltage drop across the first resistor is 15, so I'm going to put that here. The voltage drop across the second resistor is 30, and I'm going to put that here. And across the last one, that's resistor number 3, I'm going to put my 45 right there. Now I'm going to go ahead and get rid of all of my other scritzling on the paper just to clean things up a bit. Okay, to figure out the power that's dissipated at each of those resistors, and in the case of resistors, that would be power that's dissipating into heat. If these were light bulbs, it would be power that's dissipating into light. If it was a motor, it would be the amount of power that was dissipated by the motor turning something. Okay, so to figure that out, we need a power formula, which we don't have down here. But the power formula is suspiciously like these other formulas, and we'll do it P, the power, equals the amperage, which is I, times the voltage drop, which is E, at each stage. So P equals I times E. So if we take that for the first one, up here, we're going to say what's the power that's dissipated there? Well, we're going to take P equals I. I, we know, is the amperage, which is over here, the 3 amps, times the voltage drop, which in this case is 15 volts. So the power is going to be equal to 45 watts, 3 times 15. If we keep going, the next one is the power, and I'll call this P1. Next one will be P2, and that's going to be the amperage, which is the same, times the voltage drop, which is 30. 3 times 30 equals 90. That's how many watts. Okay. And finally, P3 equals 3, the amperage, don't forget it doesn't change throughout the circuit, times the voltage drop, which is 45. So here we have to do a little bit more math. We say 3 times 5 is 15, and carry the 1. 3 times 4 is 12, so it's 135. So we now have this many watts. And because we're solving this circuit, we want to know what the total power is. So that's equal to P1 plus P2 plus P3, which is 45 plus 90 plus 135, which is equal to 270 watts. So that's the total amount of power dissipated by this circuit. So I'm now going to write the power dissipated at each one of those resistors. So the first one up here is going to be 45, and that's watts. The next one down here is going to be 90, and that's watts. And the final one down here is going to be 135 watts. Okay, that's kind of it. We have solved this circuit. We've figured out what the total resistance is. We've found the circuit current, 3 amps. We've found the voltage drops across each of the resistors. And we've found how much power is dissipated across each of those resistors. So we've done our job. Congratulations, guys. And hopefully this will help you do the solve the puzzles and the rest of your assignment. Thanks for watching. Bye.